All right, let's continue on with our experiments with different forms of functions and try something even more complicated than what we've seen up until now. Again, trying to get some sense, not a sketch, not a detailed diagram, but something that gives us an idea about the shape of a function. Here's a mixture of a cosine and a parabola, and notice they're not combined in a nasty way, they're simply added together. So let's see what might happen as we explore the kinds of tools and approaches that we've used already to this more complicated function. Well, if x equals 0, we try that, we're going to get z equals cos of 0 plus y squared. And cos of 0, of course, is 1. So we would obtain a parabola. So when we let x equal 0, and we look at the consequence in the yz direction, we would have a parabola that opens upwards and that has an intercept of 1 in the yz plane. Well, what does that tell us about the intersection between the surface? Well, we have that parabolic shape. Now, what happens if we change our x values? So think of what this means. This means if we're thinking about the yz directions, we're moving out of the page. So the x-axis is coming out at you this way or straight back. It's hard to sketch that with a pen on a flat diagram. I usually wave my hands a lot in class right now. But coming out of the page towards you at pi over 4 and pi over 2. Well, at x equals pi over 4, we would get z equals cos of pi over 4 plus y squared, and that would be 1 over root 2 plus y squared. At pi over 2, we'd get z equals cos of pi over 2 plus y squared, which is 0 plus y squared, which is just y squared. So in terms of shapes, we desperately need our axes here to make this interpretable. We had a parabola opening up before, that was at 1, now it's at 1 over root 2, and then the third parabola we would draw would be at height 0, have an intercept of 0, all of these being YZ plots. So as we come out of the plane or out of the board towards you, we have the parabolic shape, but it's moving downwards because of this cos term here. Okay, so what does that look like when we put it all together? If we think about the 3D shape with y, z, and x here, we had a parabola in the YZ plane. Then it moved downwards. And then it moved downwards again. So pi over 4, pi over 2, and again, I'm trying not to sketch this too much. But we see a marching line of parabolas where the parabolas, the base, the vertex of the parabola, is going to follow the cosine curve. So what I like to think of this is as a marching line of parabolas. Moving up and down according to the cos function, to the cos of x function. So we start off with a parabola and then we get a sequence of them going rah. So think of it as a valley you're in, parabolas, and then the valley goes up and down and up and down and up and down and looks an awful lot like this. Again, it's important to have the imagination if you can, if it's at all possible, but this is what the shape would look like. We see that parabola and then we see the cosine waves happening as we move out of the plane. So the axes here would be something like, probably not there, probably closer to here. That would be the x-axis there, and y, and x. So every time we fix the x value and we just have a yz relation, we get a parabola. As we move outwards in x, we get this waving line of parabolas forming the surface. So it's quite an interesting shape, I think. I hope you think so too.